Well, good morning, everyone. Thank you all for coming to witness my talk. I don't know how to say this. I prepared a kind of a short presentation because it's my first time talking in this way, so I have no idea how things are gonna go. But well, my talk is about, as the title says it. It's a purely historical point about possible connections that can be traced between Russell's views in the philosophy of mathematics and the axiomatic set theories in general, but particularly Zermelo. Well, as is well known, the development of mathematics in Principia Mathematica, it's much better known for its shortcomings than for its merits. And among Principia's shortcomings, perhaps the most serious and certainly the most well known is the need for an axiom scheme of reducibility in order to ensure the probability of several important principles in set theory and in mathematics in general. But in particular, the possibility of proving extensionality principles for what one called the virtual theory of classes and relations in extension. In other words, properties which should be coextensive define the same classes, but in things in a very rough terms. But also, as is well known, you cannot show that each individual natural number is not the empty set without an axiom of infinity, a shortcoming that is also well known about Principia's theory of types.
Well, gatinha bonita, beijo na gatinha bonita.
Well, in light of these shortcomings, Zermelo's axiomatic approach to set theory received a far more receptive response from logicians, mathematicians, and philosophers in general, are seriously engaged in Zermelo's axiomatization or any of its subsequent modifications. Another section that is Quine's system, which he briefly considered on my philosophical development. If anyone is interested in the quote, I have it as an appendix in my presentation. I can talk about that later. But my modest aim here is to provide some clarifications as to why that is the case. My main concern is just to trace some fundamental differences which motivate Russell's approach and Zermelo's approach, and to explain why that is the case. Why is that is the case? Why Russell never bothered to really address in published writings or unpublished, for that matter, Russell's views and his system of set theory. Well, my presentation is just divided in 2 points. First, I'm gonna consider briefly what little Russell said on Zermelo's axioms in 2 letters, which is all that we have on the matter. And second, but the more extensive part, I will try to compare the 2 approaches, tracing some important, what I take to be important points of important differences in their views. Well, to begin with, unfortunately, what little we have that Russell talked about Zermelo's views, with whom he corresponded for quite a long time, and which resulted in a very interesting and rich correspondence. But well, in the 2 letters, Russell briefly considers Zermelo's axiom of separation, which is in practice the comprehension scheme of his system, and the consistency of his axioms and his construction of natural numbers. The full letter I also have as appendix for if anyone is interested in what exactly Russell said. I have it as appendix also. But the details are not really important. What is clear from those letters is that Russell's points clearly display his conviction that the theory of types was the solution for the contradictions, and that he was not really interested in considering alternative approaches to his view as that of Zermelo. Well, Gretton Gibbs wrote a book on the correspondence between Russell and Jordan, observes that the point raised by Russell was, in fact, just reveals that in quote, referring to his method, namely the theory of types, he was referring to his method, the theory of types, not as a way of avoiding the paradox, as Zermelo did, but as a way of solving them. So, as Russell later put, what he required of an actual adequate reformulation of the foundation for the foundations of set theory should satisfy three requisites, namely that it should make the contradictions disappear, it should leave as much mathematics as possible intact, which both points are clearly satisfied by Zermelo's axioms. But thirdly, and that is the point I want to emphasize, Russell required that it should be well motivated philosophically, or as Russell put it, it should appeal to what we may call logical common sense, or as Russell would say. Well, before adopting the theory of types, which is framed in Principia in terms of a no-class theory, that is a theory which abandons classes completely, Russell considered two foundational theories which are of interest for us here. The first was what Russell called a limitation of size theory, the basic idea of which was to impose, quote, a certain limit to a size of which a class can reach, in order to show that, quote, any supposed class which reaches or surpasses this limit is an improper class, that is, a non-entity. Well, the approach which Russell also considered at that time, in which he ended up adopting, was a no-class theory, which is just says that no class and no relation in extension at all is a genuine entity. This is a fundamental point because, well, the theory of types which Russell adopted in Principia is a modified version of what he called then in a no-class theory, because Principia's class expressions are contextually eliminated in Sacrament 20, as is well known, and in practice, however, the theory worked as what we nowadays call the simple non-cumulative theory of types, in the presence of the axiom of reducibility.
Okay, let's just wait for his connection to come back.
Although Russell's, well, yes? Okay, I'm so sorry. It must be my connection. Well, going on. Well, the point here, the central point which must be taken into account if you are to understand what led Russell to reject Zermelo's axiomatization in his approach in general is the fact that Russell's discovery of the paradox in the foundations of naive set theory made the entire concept of class or sets dubious from him. In other words, Russell came to be completely skeptical of any attempt to simply overcome the contradictions by in such a way as Zermelo attempted, which was to simply circumscribe a satisfactory concept for the purposes of mathematics without giving a really philosophical foundation for the theory of sets. As Russell put in a letter to Frege from around 1902, every day he wrote to Frege, I understand less and less what really meant by extension of concept. Well, it was this mistrust of the concept of set in general which led Russell to adopt this radical view, according to which all sets are ultimately not entities of their members, and two, to reform laws of logic which underlie classical mathematics, that is, introduce distinctions of type. Zermelo's motivation, on the other hand, markedly contrasts with that of Russell. As Gregory Moore, who wrote a very important book on Zermelo's axiom of choice, observes, in Zermelo, in profound quote, Zermelo, in profound contrast to Russell, saw thought the paradoxes were an essential obstacle to be circumvented with as little fuss as possible. There is mainly Zermelo's motivation for axiomatizing set theory was mathematical in character. His main preoccupation was to secure his proof of the well-ordering theorem and establish his axiom of choice as a legitimate mathematical principle. So these different motivations behind the approaches.
Rodrigo, just sorry to interrupt you. I
Yes.
think we can't see your slides.
Oh.
It's another screen. You can unshare the screen and then share again, and you choose the
Okay.
the PowerPoint because it's another tab.
Okay. Now can you see it?
Yes.
Oh, okay.
Thank you.
Thank you, Ricardo. Well, these different motivations behind the approaches to the foundations of mathematics in Zermelo and Russell manifest themselves drastically in how they understood the status of existential theorems, in particular those that involved assumptions of infinite totalities. And I'm using an example is given by the way both Russell and Zermelo handled transfinite arithmetic. Principia, for example, for instance, cannot prove the existence of an ordinal like omega, which cannot even be defined because it would require a limit or basically rejected. Zermelo's set theory can in a sense be understood as a sort of generalization of Russell's theory of types. All that is required is that we eliminate some inconveniences of Russell's type theory, which namely we must let types accumulate, the types must be finite, that is we allow transfinite types like omega, and we abandon the grammatical approach to types. Yeah, that is we treat expressions like alpha belongs to alpha as false instead of ill-formed. Such provisions greatly increase the flexibility of the formal system, and in fact, doing this, as Gödel, Quine, and many others showed, this simply amounts to adopting a theory like that of Zermelo's. Well, framed in these terms, we may see clearly why that Russell could never come to accept such approach like that of Zermelo's, because such implementations go up against core philosophical views that the main point, I take it, is this. Liberalizing type theory in such ways as indicated amounts to treating sets on par individuals in all important aspects, most importantly from the ontological point of view. But the fact is that Russell's whole acceptance of type distinctions, as he put in Principia and previous works, went hand in hand with this view that sets were what he called logical constructions, which must be essentially distinguished from individuals in any suitable interpretation of his views. Well, the approach, such as Zermelo, amounts to collapsing within a singular type individuals with sets of individuals with sets of individuals and so on, which completely violates the fundamental Russellian distinction between genuine entities and logical constructions, which was the cornerstone of Russell's motivation for adopting a theory of types. This, on its turn, goes against another fundamental Russellian idea, namely that inadequate reconstruction of mathematics must avoid as much as possible the postulation of mathematical objects in favor of their construction. Well, from the perspective of Principia's original genuinely simple type structure, the collapse of types, which is at least implicitly implied by the axiomatic theory of Zermelo, simply obliterates such a distinction. For all intents and purposes, the allowance of cumulativity ignores the distinction between individuals and sets of any type. That is, sets of individuals, sets of individuals, and so on. In fact, even if there are only finitely many individuals, or Zermelo's Iure Elemente, or none at all, the development of mathematics goes on just the same. Well, which contrasts markedly with the type theory of Principia, which requires, in virtue of Russell's constructive method, requires the existence of sets of individuals to construct natural numbers, real numbers, rational numbers, and all the entities of transfinite arithmetic. That is, the possibility of constructing numbers in Principia Mathematica depends essentially on the existence of sets of individuals on the bottom of the hierarchy. So, needless to say, many have understood this as another shortcoming of the resilient development of mathematics within the theory of types. I'm not going to enter on that question here, but that may or may be not the case. It's an important and very old and complex debate. But Russell fully accepted these consequences, and there seems to be good reason for viewing them as a coherent part of his views, as recent authors like Kevin Clement and Gregory Landini have argued extensively. But be it as it may, I think these considerations afford us with some insight as to why Russell never really seriously bothered with Zermelo's axiomatization of set theory. Thank you for listening, and sorry for the technical issues here with my connection. Here's a picture of Zermelo and Russell around 1908. I usually joke that this is the only picture I know of where Russell has a mustache, and I joke that it probably fell off in virtue of the toil of writing Principia Mathematica. So thank you for listening again.
Thank you very much, Rodrigo. So we can hear you perfectly. We just don't have your video, but
oh, okay.
That's good. But we can hear you. At least I'm hearing you perfect. So we have open for questions. Let's see, the times. We have 8 minutes for questions. Now it's 11. No, it's 10 a.m. Right? 10. Yeah. I have a different.
Yes, here is 10 a.m.
Yeah. Yeah, I was.
Yes.
I need to.
Yeah. Not 11 p.m.
Yeah. So we have the question box. So it's just like you can write your question or just write that you have a question, and I will open the microphone. So no one has a question?
So,
just...
I would just like to question Rodrigo about his intentions with this research. Which would be his main intention with this theoretical research? Which are his goals? Which are your goals, Rodrigo?
Well, this topic, my PhD thesis, which I'm currently working on, is a historical reconstruction of Russell's trajectory from the principles of mathematics to Principia Mathematica. It's a historical work on the development of his views. This is a part of a chapter, the difference between Zermelo's approach and Russell's approach fits in my research in the more general problem of how Russell understood the nature of mathematical entities and how he viewed the possibility of providing a theory of logic which afforded or did not afford mathematics with its necessary objects. My aim with this, more broadly within my research, this is just one aspect of comparing Russell's views on the ontology of mathematics with his contemporaries, namely Zermelo, Frege, and Poincaré, and authors with whom he was discussing at the time.
Thank you. Now we have a question. Juliet Floyd has a question. So, Juliet,
okay,
you can
I'm
just...
muted. Can everybody hear me?
Yes.
Yes.
Rodrigo, thank you. That was really a wonderful talk, very clear. And I think your project is really interesting. I have a question also, like Sophia, about the import of this historical work, because actually there are many interesting things about the interplay between the purely extensionalist approach connected with Zermelo and the mathematical development of set theory, and the non-extensional approach coming out of the philosophers who are interested in concepts, the nature of a proposition. They're interested in these more, let us say, non-extensional aspects of the ways in which we formulate truths about sets. And I would think that what you're doing is going to be very interesting when you look ahead to the students of Russell's, like Ramsey, like Wittgenstein, to some extent indirectly Turing, because this argument about the extensional versus the non-extensional approach, even in mathematics, is part of the Cambridge context and the legacy of Russell. So I realize this is probably beyond your dissertation now, and I don't want to put too much on your plate, but I think that you're doing something that has future research potential.
Well, thank you very much. Yes. This is, I think, the fundamental difference is which for quite a long time it's actually surprising. Many authors who have discussed Russell's views have downplayed it. That Russell was intentionally, no pun intended, trying to formulate mathematics within a view of logic as intentional logic.
Right.
So, for instance, it took like 7 years to Church, for instance, to observe that despite the fact that introducing the axiom of reducibility into the system of Principia amounts to adopting a theory of types for extensional cases, which are relevant for physics, if you attempt to formalize within the logic of Principia intentional operators like believe or knows and so on, you preserve completely the structure of the ramified theory of types. So yes, I think the fact that Russell was interested mainly in putting mathematics within an intentional logic is of fundamental importance, and there is I agree, there is a ton of research to be done exploring these themes, both by them, not only historically, but as fundamental philosophical issues by themselves.
Mm-hmm. Thank you.
Thank you very much again, Rodrigo.